Traceable AI. So I'm a technical evangelist here at Traceable AI. Been in the DevSecOps space for quite some time. Really excited to share with you and talk about kind of what we're seeing is happening, and what we need to think about around that, around API security. So if you could I get the next slide? Just realized I can't advance. Thank you. So we're going to talk a little bit of context, what's changed, what's needed because of that change. Unfortunately, I'm not going to be able to pull it up and show it to you live as was planned because of this technical difficulty, but we'll go into Q&A instead. So if you go to the next slide, please. Context. So I was thinking, how could I say what everyone has been saying since Mark Andreessen first coined the concept of software eating the world, which clearly happened. We're in a new state, and some will argue it's not that new, but it has really taken off where if software is eating the world, APIs have eaten software and hence the world. Next slide. So because of cloud and cloud native and microservices and API-driven apps and mobile phones and you name it, the DevOps success, CI/CD, the drive of businesses realizing the digital transformation and the need to push forward and to change rapidly, the adoption of APIs has become pretty much ubiquitous. A couple of years ago, IDC predicted that by this year, 90% of enterprise applications would be API-driven architectures. Haven't seen the follow-up on whether or not that's true, but it would not surprise me in the least bit. APIs connect everything. Next slide, please. And so APIs connect everything, and there's a growing security crisis. Now, I'm not here to be a fear monger. I'm here to talk to all of us. The reason that we're at this conference is because we know something's going on, something you could even say unprecedented, but something that needs attention. Security around APIs has not advanced as quickly as the adoption of APIs, which has been long in coming. We've kind of hit the elbow on the curve, on the hockey stick curve there. API adoption is rampant, again, because of all those things I talked about earlier. We're hearing anecdotes, we're hearing from customers, we're hearing from analysts, we're hearing and seeing the attacks that are out there are happening more and more against APIs. And so I know it's not preferred to put names on a slide and say like these people were attacked. These are all very public. And this is not to finger point and say, hey, they didn't know what they were doing. This is our community, right? And the reason that I put these folks on this slide, all of them in recent times have had serious API attacks where they lost data, they were breached in some way, sense, or form, whether it was fraud or whatever, because of attacks on their APIs. Now, the reason they're here is because like a lot of these companies are kind of the tops in technology, right? Many are internet born. And you can be pretty sure that most all these companies have a pretty serious, well-trained, some of the best in the world security folks and a budget, and they know that security is important. So what's happening here, right? Why are we still seeing, every quarter or so a major API leak, or a major attack happening? Let's dig into that a little bit more. I think Greg Phillips, CTO at Hauser, one of the folks we talked to, said it very interestingly. We're in an industry that's constantly under attack. And when he said we're, he's talking about the software industry. He's talking about his fintech industry that does real estate agent online. But we're all in the software industry because software has eaten the world, right? Security Magazine, did a survey and said 91% of organizations that they surveyed had a security incident last year that was related to APIs. So let's move on. Next slide, please. So why is this happening? Let's step back a little bit and kind of look at how we're getting to where we are before we talk about where we need to go next. Um, the days of yester passed, right? We had a smaller attack surface, right? There were fewer components that were part of an application and fewer APIs that were part of the attack surface because of that. And those APIs that we did have out there were slow to change. We didn't have these rapid development cycles that we do today. There was also limited sensitive data. You might have a service talk to a backend and exchange the data in the middle and then pass it back out. So there was less sensitive data moving around, was more controlled. And overall, as I mentioned, there were fewer components that were part of applications, and hence a smaller attack surface in general. But also those attack types were different than we see today. Most of the attacks came from the external. The web attacks or the known attacks that we started learning or dealing with were ones that could be dealt with through signature-based solutions to a degree. And they were more single attacks, more like playing checkers, right? I'm going to go hit this with a certain payload and I'm going to get it or I'm not, right? And so that was before. If you could go next, please. Today, right, because of, again, the proliferation of microservices and cloud native solutions and so many of these new technologies, the attack surface has changed drastically, right? APIs are everywhere. We're dealing with apps that can have hundreds, if not thousands of components communicating. And because of that, again, the APIs are that means of communication. Those APIs themselves frequently change because we're now rapidly developing and changing the pieces of the application while it's running. Because of our knowledge and understanding of how to do this has grown now. And there's a lot more sensitive data being handed off between one system and the next, between one API and the next. So that's a bigger attack surface by far, not just the number of components, but also the number of APIs coming from those components. And the attacks now can come from within as well as external. We have this business logic attacks, which are now more prevalent, where someone might be using an API the way that it was designed, but they figured out a way to use it to get data that they weren't supposed to get, or it wasn't designed well, and there's a leak in it that, stacked with some other vulnerabilities, can lead to a breach. We have more unknown attacks, and this makes more sense in a way because each app tends to have its unique set of attacks, right? If it's based on the business logic, if it's based on how the app is put together. So we have a wider spread of how to get data out of a system that you shouldn't be getting access to. And the attacks have become more complex. They're multi-steps over time, more like playing chess, right? And before I move on from this, there's a great talk tomorrow as part of the opening keynote where Enon Shketi, who is one of the leaders of the OWASP API Top 10, will be going in depth on more multi-step complicated attacks. I've seen the deck. It's going to be a really good talk. So I encourage you to check that out. Okay, next slide. On the other hand, I am going to show a simpler version of an attack, just again, so we can level set, make sure we're reaching everyone and helping them understand. So yep, so there's the first one. Oh, hold on. So the first piece here is a client, whether the bad guy or not, we don't know yet, makes a call. So this is actually an actual attack that happened to a ride-sharing company. We'll keep the name undisclosed. And they have this really great capability where you can actually, as a driver, refer your friend to also become a driver. And what they did, though, was they have a different system set up for actually the creation of the user ID that happens through this referral. And that means that they have APIs that had maybe different levels of security. Maybe it was abandoned or not, maybe it was orphaned. But what happens with this with this API is the client or the poster makes a request to join the referral program. In the backend system, the API then generates and returns a valid user ID that is now assigned to them. Now, what is expected to happen is that will come back. The client will then, and this is the client on the phone or the system or the computer, will then take that ID and then make a request back to get the consent details. So this is now going to get the information on the forms and everything that they have to approve of, sign basically. And then that is supposed to then return the data of the consent details in a JSON object, a user object, back to the client. The expectation is that the client will then strip out the stuff it doesn't need, and it will show to the user the information that is needed, and that user will then approve, and they'll move on, and all is good. If you go next one more, what actually happens in this attack is the client then says, "Okay, I'm authenticated. I'm going to go see if I can get a different user ID." Now, maybe they're not enumerated well. Maybe they got this ID off of someone else's app, or there's a list for sale out there, or there's many different ways that they could find IDs out, even if they were better obfuscated. But what this attacker does now is return with their authentication and say, "I need the user ID, this user ID information." I'm doing the get consent details API call, endpoint call, and they return someone else's ID. And the API, not doing proper authorization, went ahead and returned the information for the other user ID. Now, you can see what's happening here. And one of the problems is that that JSON object was more than just a paragraph that they needed to sign. So if you go next, please. Thank you. So what happened? So at least two things happened here. One of which was the broken object level authorization, BOLA, which is the #1 API vulnerability on the OWASP API top 10 list. Now, that meant that the system had proper authentication, but did not properly authorize that that authenticated user was able to access the object they were asking to see. So that meant that they were able to ask for an object that wasn't theirs, but that got paired with, and usually does get paired with, excessive data exposure. And this is this business about the JSON that I mentioned earlier. JSON makes it easy to return data. As a matter of fact, the frameworks, the languages, everything we have encourages this because it's more convenient and efficient for developers to say, here's the whole object. And what happened then is there was a trust that the client would strip out the information that wasn't supposed to be seen. Rogue client, attacker, doing whatever they're looking at the return, they're able to get all the information. So the JSON object included personal identifiable information, of course. The authentication tokens were stolen, and a full account takeover happened. So that's just a small example of a BOLA attack in this case, using APIs. If you think about this from a web attack perspective, it just looks like web traffic, and what the number is doesn't mean really much. And you could even say, well, hey, wait a minute, how hard is it really to say the user ID versus that's making the request versus the user ID that is being requested? We can do a check there, and that's true. But this can also happen over many sessions, right? This can happen in many different ways. So there are deeper, more difficult BOLA attacks to identify and to protect against. And those require really having good information about who the user is, who's making the requests, and connecting those over time, over sessions, and tracking that user no matter how they're coming in, whether they've reset their session cookie or not, etc. So next, please. So you might be saying to yourself, yeah, but how does this happen, right? Very rarely is something like this um, the mistake in the API malicious or intentional. Um, the use of it typically is to get data out. However, if we think about how we've been developing now and our switch to APIs, here's some examples of how these security flaws, these types of flaws might get introduced, right? The API is coming from a trusted source, AWS or Hulu or eBay or what have you. So it must be secure, right? And granted, there's a degree to which we have to believe that so we can move forward and be productive. But we should also apply the concept of zero trust everywhere we can in a way that helps us with apps. We don't know that an API, we've seen proof actually that even big companies that are good tech companies that have good, technical resources around securing their APIs, creating their APIs, make mistakes, right? So the next one, I need to modify this API and get it shipped now. So this notion of being under pressure and you've got the code in front of you and you just need a tweak, right? Well, that tweak could change the intent or the behavior of the API in a negative way or open up a hole. So the pressure to ship in general is what we're talking about here, and not always seeing the implications of changes being made to all the software, all the APIs. I need to quickly make an API without designing it. Again, similar to pressure to ship, or if you're developing a little something and you need to create an API to give access to a partner or somebody internal, and this bleeds into the next one, right? This happens more often than not. This is an internal only API. This is a service that's going to serve internally. So I don't really need to have as much authentication, authorization, security around it because it's safe, it's inside. But more often than not, too often, especially if you have good services, they get picked up by other tools. They can get turned to be used externally. An example of that may be an internal tool that you now are going to let partners have access to, right? Now it's an external tool or API rather. And so a good practice there is to always assume that the APIs you create are going to be used externally. And so always do the higher level of security around them, authentication, authorization, validation of the holes in the business logic. Another one is the API gateways handling the security, right? So we're good. Now, API gateways are great, and they do provide a level of security, authentication, some authorization, rate limiting, etc. But an API gateway is not going to catch like the example that I just showed, where something more detailed in the API call is getting manipulated to take advantage of a vulnerability. And then this last one really just kind of makes worse all of the others, right? Which is, I will document it later. API documentation is a challenge. Software documentation is a challenge. There are tools that help, like OpenAPI spec, but there's still work that has to be done and documented. And when we don't document well, then we have drift between the reality and what is documented or what isn't documented. And then you run the risk of shadow APIs or APIs that don't do what are expected, and so may not reveal or be caught when they are out of sync or something that needs to be patched or fixed up because of a problem elsewhere externally, like we saw recently with the Spring for Shell. All right, next slide, please. So, what is needed for modern API security? Let's talk about that. If you go next. Just one. Yep, there we go. All right. So first, we need to know our exposure. Now, what I'm sharing here is the thoughts across whatever tool set you decide to use. What the attempt here is to make sure we're thinking, this is an API security conference, but make sure we're thinking about what are the things we need to be looking at? How do we need to go about protecting, creating, and doing working with APIs in a way that help us to better secure these APIs. So the first is knowing what you have, knowing what your exposure, your attack surface is. Complete API visibility is important. If you know what APIs you have on your gateway, and I don't mean to keep picking on those, but or in your API management system, that's good. But you don't know then about the shadow APIs, maybe not about the orphaned APIs, and those rogue APIs or those unknown APIs are the ones that are going to be the vector in, very possibly. So you can't protect it if you don't know it's there. And so first things first is to make sure that you know what is out there. Now, just doing that by documentation, again, saying, okay, if you introduce a new API, the process says you have to, add it here, make sure we're aware of it here. If the process breaks or even doesn't break, but somebody has implemented something that then unexpectedly for them pulls in another communication, another API, another service, then that's something that that we need to be wary of or watching out for. So really what you want is something that's going to be able to go out and discover and keep maintaining the state of what APIs you have out there. Along with that are the dependencies, which APIs talk with which ones are working with which and handing off data to which. Also something very valuable is risk scoring. However it's done, there's a lot of complexities of APIs that can make them higher risk or lower risk. For example, are they external facing? Do they have sensitive data? Is that sensitive data in the request or the response? Is this API oftentimes hit from a wide variety of systems, spread geographically? There's lots of different pieces of data that can be looked at and pulled together to create a risk score. The value of the risk score, however you pull that together, is that it can help you to prioritize what APIs need to be attended to and watched more closely and remediated, right? So if we talk about hundreds of APIs and probably thousands of API endpoints, which make up those APIs, then it's going to be very hard to always be sifting through all of that and figuring out which are the ones that need priority attention. So risk scoring will help with that. Understanding the data flow, the sensitive data particularly, how does it move from service to service? What APIs touch it and transform it? And are they, again, external facing? Are they authenticated or not? So understanding the data flow, since the data is really the crown jewels, right? That is the part that we really need to protect here. A very important piece of it. And then third-party usage. Like when are we calling out to third-party APIs that becoming more and more prevalent with so many great services out there that we then lose full visibility to, or that we might be sending data out to. We need to be aware of those as well. So that's understanding your exposure, what you have out there, what your attack surface is. Can you go next, please? Then there's just straight up, we need to protect them, right? We need to prevent attacks. We need to, most importantly, not assume that our web protection is adequate for protecting against APIs. I think the illustration earlier was to kind of show there's another level, of attack that is different than what we're used to from the days of WAFs. And those are still out there, right? Cross-site scripting and all of these. There are still, challenges out there and attacks that are done that way. You need both because an attacker is going to take whatever they can get, but they've now got also the API vulnerabilities to use as well, and even in conjunction. So OWASP API top 10, OWASP web top 10, or just top 10, we should be able to protect against those. And then business logic abuse. Business logic, again, being more of a challenge now with APIs where somebody can use these powerful tools that allow them to get straight to the data and to manipulate how they use them to perhaps unexpected things with APIs to get to the data that they want to get to. API abuse, fraud, bot protection, and unknown attacks, right? The 0 days. These are all prevalent at the API level as they were, as some of them were at the, the web level. But there's more of it now that we need to be conscious of and protecting against. Next, please. Next slide, or next click. Thank you. All right, so contextual awareness, what does that mean? We need to build contextual awareness. So going along with the fact that we now connect to so many services or microservices as part of our applications, and we can call out to use third-party services and partner services, and the data is being handed from place to place, the ability to understand holistically what is happening with your application requires contextual awareness. That means understanding when you make a transaction or a call, that is not just happening within, from your source to your destination, that there's very potentially a lot going on beyond that, and within that, right? And so having the awareness of how your API calls, where they're traversing, and what they're connecting to, and being able to trace the set of communication, and this comes down to distributed tracing, or whatever technology you use, to put together the sets of transactions into sessions that you can, or traces that you can understand and look at, getting the request and response headers and bodies, having this stored, where, not throwing out or sampling the data, but having it so that it can be looked at, help with things like root cause analysis, which is extremely difficult to do in distributed applications, user behavioral analysis, threat hunting, troubleshooting. And so this is the next level up, of clarity we need to have of the system around us in order to be able to do these things. And one more, please. And of course, we need to develop secure APIs, because it doesn't do us any good to just react. We need to make sure that from the beginning that we're doing what we can to help secure the APIs, as far left as we can. This means, from an API perspective, being able to look at our APIs and apply best practices and get feedback on whether or not we're following them. Same thing with company policies, which may say something, for example, you are not allowed to send out sensitive data if it's unencrypted, certainly something we could check for. Being able to identify vulnerabilities in the APIs, in the code, at runtime as well. So the combination of those, of runtime vulnerability and static code checks, make sure that we know for sure when we have a vulnerability identified, being able to track that life cycle of that vulnerability until it's resolved, whether that is within the tool of your choice, or integrated with popular tools like Jira. Very important to make sure that we get this data back, especially from runtime, when we can see the full breadth of everything that is connecting and communicating. Security testing, API security testing, there's a lot we can do and need to do around bringing, for example, runtime production data back in to do our set of testing against the APIs. API testing is a little more challenging from a security perspective, because there could be several steps across multiple systems that need to happen in order to create the opportunity of a breach. And so how do we replicate that? How do we make sure that that's not possible? One is knowing that that exists, that there is that several step situation, so that we can then figure out where we can, stop it from starting in the first place. And then that testing needs to be integrated into testing integration and CI/CD. For example, part of a CI/CD pipeline should very well be taking in data from operations, from runtime, that says, hey, this API is high risk, or has become high risk, or has been breached a number of times, and you're about to deploy a new application that has it, right? So there's more we can do there and that we should be doing and looking at. Next slide. Real quickly on this, I talk about that contextual awareness. This is kind of a little bit about that. Where is it easier to find the problem? When you have an external partial view, as our medieval doctor here does, or our doctor with the knee hammer, or next, or the modern day doctor who has an MRI machine can scan external and internal and see how all of the pieces interlock and see how they work. And have a full view of how everything is connected. I think we used to be like the medieval doctor here, or colonial, I guess. We are moving more towards and need to be more like the doctor on the right. Next. And so, how does that look from an applications perspective? And so here's just a mock-up of an application, but if you go next, please. The first thing is we need to be able to know who our users are, what their activity is. We need to have user attribution so we can say that transaction was from this user. And this set of transactions now are correlated because of that. And that means also not just what username came across the line, but when they change their IP address or when they change their session cookie or reset their token, right? So we need to be able to correlate that, put that together and understand what they're doing holistically. What devices are being used? What are the roles and permissions? Next, you can just next. API, and then stop at one more. API activity, right? What are our APIs doing? That's perfect, thank you. How are they communicating? Which ones are edge APIs versus internal? What are the sequence of those API calls? What is usual so that we can baseline and find what is anomalous? And this is across all of the pieces of the system. Where is the data flowing? How does it get handled across which API calls or which services? Is it moving between internal services only? When does it get go external? How is it being transformed and converted? So the data flow is an important piece that we need to collect. And then at the code execution level, the API parameters and what and the attributes and what are they and what is typical for this particular parameter? What are the character sets we should expect? What is being made available that has sensitive data, right? What is the classification of that data? Looking at the request response data, the body information, and as well errors and latency, right? You think, hey, this is we looked at that for performance and for general uptime. That's also a signal for security, right? If my errors go through the roof or my cycles, my CPU cycles do. So we need to look at all of that together. Next slide. And together, those bring us full application context. Next slide, please. Thank you. In those pieces, user activity, API activity, data flow, code execution come together into a machine learning system, and I think that's what we need to do at this point. The amount of data that we need to collect to fully understand what is happening with these complex applications is more than even a team of people are going to really be able to correlate across and find anomalies in. So this is where machine learning, and I know it's buzzwordy, everyone says AI, everyone says machine learning, but really it's needed to sift through the data. The more data you feed into machine learning, the better results you get, the more accurate results you get. And so we want to collect as much of the data around API usage as possible so that we can feed that into the machine and get the best understanding of baseline versus anomaly and attack behavior. Next. A combination of those gives us what we call full application context. This means we understand the behavior of our APIs, right? When do they get called? How do they get called? What's normal and what's not? Understand the behavior of our code, of our users, of the data, and then what kind of risks do we have, and how are our users? Do we trust them, et cetera? Kind of a karma thing. So a lot of this information gets derived all this information gets derived from the inputs plus the machine language and external inputs. And having this application context, one more click, please, allows us to do all of those great securing capabilities, like business logic attack detection and unknown attack detection, and you can read the list, but low false positives, threat hunting, forensics, etc. And so, last slide. I think I'm actually at the top of my time. Go ahead, one more, please. I think that was it. Last slide. Or maybe I lost. Okay, there you go. So, like I said, apologies. I'm not going to be able to go live. I am doing this talk again tomorrow, and you can also contact us if you want to see some of this. Again, as an example, we would do it in Traceable, of course. But really, it's the concepts I want you to take away from this of what we need to be thinking about regarding API security. So with that, thank you. Apologies for the technical difficulties. Thanks for hanging in there, and hope to talk to you soon. There's a contact slide at the very end here. If you could 2 slides forward, I think. Oh yeah, I was going to use this as a backdrop for the demo. Just go through this. One more. I don't think we have time for Q&A, right? So anyways, feel free to contact me, and thank you.